We expected to find the derivative of cot inverse of 1 over x squared. Now before we could obtain the derivative of cot inverse of 1 over x squared, I would like to show you what is the derivative of cot inverse of x. This is a very valid question. Now you can search the answers for this particular question, but most of the solutions that you would come across wouldn't be straightforward. So that is the reason I have chosen to present the solution here. Now foremost, let us assume that we are expected to find the derivative dy over dx for cot inverse of x. Now if I were to move this cot inverse to the left side, I would get cot of y is equal to x. So this is fair enough, right? So now what I wish to do is I would like to differentiate both sides with respect to x. So if I were to differentiate this, what do I get? Differential of cot is going to be negative cosecant squared y times differential of y, which is dy over dx, and differentiation of x will give me 1. Now let me push this negative cosecant squared y to the right. So this is going to be dy over dx is equal to negative 1 over cosecant squared y. But what is cosecant squared y exactly? Now we know that, let me state that. Cosecant squared x negative, or how would I put it? Probably I will just write it like this. Cosecant squared x is equal to 1 positive cot squared x. Now why do I write this? Because the original formula is actually represented like this. Cosecant squared x negative cot squared x is equal to 1. So from here I can rewrite cosecant squared x is equal to 1 positive cot squared x. Now we know that cot y is equal to x. So what I would do is I would be using these two formulas and I would be rewriting. So if I were to take this as 2, so these are all for your understanding. This has got nothing to do with the problem. Probably maybe I will just place this in red. So now because of the understanding we have got, I can rewrite 2 as dy over dx is equal to negative 1 over 1 positive cot squared y. Right. Now what do we have here? Okay, maybe I'll take this as 1. We got cot y is equal to x. So I'm going to rewrite this as negative 1 over 1 positive cot y raised to the power of 2, which is equal to negative 1 over 1 positive cot y is x, so this is going to be x squared. So now what have I got? I've got dy over dx is equal to, let me write that down, therefore dy over dx is equal to negative 1 over 1 positive x squared. So this is the solution. So students, let us obtain the derivative of cot inverse of 1 over x squared. Now we know that, I'm just stating the result which we just saw, d of cot inverse of x to be as negative 1 over 1 positive x squared. So I would be using this result. So this is equal to 1 over, of course there should be a negative sign, 1 positive. In place of x I will be substituting 1 over x squared, but we got a degree to be 2, so I need to place that 2, times this has to carry a derivative of 1 over x squared, right? So that is very critical. So what I wish to do is I would like to show you how this derivative is obtained. So let me use the space here. So this is going to be d of 1 over x squared. I can rewrite this as d of x to the power of negative 2. Now I can use this formula, d of x power n is equal to n times x raised to the power of n negative 1. So by this formula, this is going to be negative 2 times x raised to the power of negative 2 negative 1, which is negative 2 times x raised to the power of negative 3, which is negative 2 over x raised to the power of 3. So this is nothing but differentiating x raised to the power of negative 2. So I can fairly substitute that. Now foremost what I wish to do is I would be simplifying this. It's going to be negative 1 over 1 positive 1 over x to the power of 4. Now I can place this differential negative 2 over x to the power of 3, which is equal to negative negative positive 2 divided by, the LCM is x to the power of 4 positive 1 divided by x power 4. This is one term, followed by 1 over x to the power of 3. So when I flip it, this is going to be 2 times x to the power of 4 divided by x to the power of 3 times x power 4 positive 1. Now clearly x power 3 and x power 3 present in the numerator can be removed. That would give me 2 times x divided by x to the power of 4 positive 1, which is my solution to the question. So this is a good place for us to draw the red line.